Another important theory is the treadmill of production. It was developed by sociologist Alan Schneeberg in the 1980s, and this theory offers a powerful critique of how capitalist economies operate, and more importantly, how they generate environmental degradation and disaster vulnerability as a byproduct of their core logic. In a capitalist system, economic actors like corporations, governments, and even us, the consumers, are locked into a cycle of continuous production and expansion. Firms must grow to remain competitive. Governments must promote growth to maintain employment and tax revenue to maintain popularity. Consumers are encouraged to spend more to sustain demand. This creates a self-reinforcing loop. More production leads to more resource extraction, more pollution, and more ecological disruption. The treadmill metaphor here is key. This metaphor captures the idea that we must keep running. Producing, consuming, expanding. And if we don't keep running in this way, we risk economic collapse. Many of us have probably used a treadmill before, but unlike a treadmill at the gym, this one doesn't lead to fitness. It leads to environmental degradation and disaster. The environment is treated as a limitless input and a bottomless sink. Forests are cleared, rivers are polluted, and carbon is dumped into the atmosphere, all in the service of economic growth. And because these environmental costs are externalized, meaning they're not accounted for in market prices, they're often invisible until disaster strikes. Let's break down how this works into 4 key components. First, there's the growth imperative. In capitalist economies, firms must expand or risk being outcompeted. This drives technological innovation, but it also intensifies resource use. Because efficiency gains don't necessarily reduce environmental impact. They often lead to more production overall. This phenomenon is known as the Jevons paradox. This image on the left here is a cartoon that explains Jevons paradox. The paradox states that as technological advancements increase the efficiency of a resource, the consumption of that resource actually tends to increase rather than decrease. This paradox goes all the way back to William Jevons in 1865. Jevons noted that improved efficiency in coal-powered steam engines led to an overall increase in coal consumption. Whereas you would assume if trains and machines that were coal-powered became more efficient, they would actually need less coal. But that is not what happened. This comic illustrates this by showing a new, highly fuel-efficient car that can get 80 miles per gallon, and then a person commenting that because these cars are so efficient, everyone is driving everywhere. The increased efficiency makes the use of this resource, in this case gasoline, more economical, which can lead to an increased demand and overall consumption. So why does this matter? Well, Jevons' paradox challenges the assumption that efficiency alone will reduce resource depletion or emissions. It suggests that systemic changes, things like pricing, regulation, behavioral shifts, changes in the industry, are needed alongside efficiency improvements to achieve sustainability. So the first feature of the treadmill of production is the growth imperative. Second, there's resource intensification. As production scales up, so does the demand for energy, minerals, land, and labor. This leads to ecological degradation, things like deforestation, soil erosion, biodiversity loss, and guess what? All of these increase disaster risk. For example, clearing mangroves for shrimp farming may boost exports, but it also removes a natural buffer against coastal storms. Here we see a before and after image of mangroves in Mahakam Delta in Indonesia. Shrimp farming is common there. These wetland islands were once dense with mangroves. At the time of this image, half of those forests had been replaced with aquaculture ponds. Without the protective barrier provided by the mangroves, the area became more vulnerable to coastal erosion and storm surges. Attempts at mangrove restoration have not yet been successful. The third feature of the treadmill of production is environmental externalities. Pollution, waste, and ecological harm are offloaded onto communities and ecosystems. These environmental costs are not borne by the producers or the consumers. They're absorbed by the public, often disproportionately by marginalized groups. Think, for example, of toxic waste sites near low-income neighborhoods or air pollution affecting children's health in industrial zones. The Enrich Project in Canada has produced extensive research on environmental racism and proximity to hazards. It finds that marginalized communities, especially Indigenous and African Nova Scotian communities, are disproportionately located near environmental hazards, including landfills, waste disposal sites, and polluting industries. If you go to enrichproject.org, you can see a live map of the distribution of communities and toxic facility sites. And this pattern is not random. It reflects systemic environmental racism, where race and socioeconomic status correlate with exposure to toxins and lack of infrastructure. Specifically, environmental racism refers to the disproportionate exposure of marginalized racial and ethnic communities to environmental hazards due to systemic inequalities in policy, planning, and political power. Think about which communities have the political connections to ensure that new industrial developments are never located near where they live. The health impacts of living next to these toxic sites include higher rates of respiratory illness, cancer, and other chronic conditions linked to pollution. Environmental racism shows how the treadmill of production interacts with colonialism and racial oppression to produce disaster vulnerability. So we've talked about 3 key features of the treadmill of production. Now, finally, the treadmill of production operates through political inertia. What does this mean, political inertia? Well, governments are often reluctant to challenge the treadmill because growth is tied to their political legitimacy and popularity. Proposing limits on production or consumption is seen as risky, even unpatriotic, especially if elections are coming up. Environmental regulations inevitably get watered down, delayed, or ignored in favor of short-term economic gains. Now, how does the treadmill relate to disasters? We know the treadmill accelerates ecological degradation, which in turn increases the frequency and severity of disasters. Climate change, urban sprawl, deforestation, All are driven by the logic of endless growth. And when disasters do occur, the treadmill discourages transformative recovery. Instead of rebuilding differently, we rebuild quickly to restore economic activity and resume the cycle. Take urban flooding as an example. Cities expand rapidly to accommodate growth, often paving over wetlands and building in floodplains. These areas are ecologically sensitive and they naturally function to absorb excess water. But in the treadmill logic, they're seen as underutilized land. When heavy rains come, drainage systems fail and floods cause widespread damage. Yet, instead of slowing development, cities often double down, rebuilding in the same vulnerable areas to maintain economic momentum. The treadmill also helps explain why environmental reforms often stall. Even when the science is clear and the risks are known, structural pressures make it difficult to change course. Corporations lobby against regulation. Politicians fear losing their jobs. Consumers are locked into habits shaped by advertising and infrastructure. The system resists transformation because its very survival depends on expansion. So, what does this mean for disaster studies? It means we need to look beyond individual behaviors or technical fixes. Disasters are not just the result of poor planning or bad luck. They're symptoms of a deeper systemic problem. The treadmill of production creates the conditions for disaster and then limits our ability to respond meaningfully. But this theory also invites us to think about alternatives. What would it mean to step off the treadmill? Could we design economies that prioritize ecological health, social equity, and long-term resilience over short-term growth? The treadmill of production is a sobering theory, but it is also a call to action. My action, your action, our action. By understanding its mechanics, we can begin to envision a world where sustainability is not a side effect, it is a foundation.